Okay, hi everybody. We'll go ahead and get this session started. Just kind of wanted to spend a few moments up top explaining exactly what we're doing here, kind of what the idea is. So every week we're going to ask you to do some prep work before you come to class on Thursdays, which are studio days. The idea is that there's some readings and things that you can do on your own before showing up to class so that you'll be able to make the most out of the time that you're there to work with your peers in class on Thursday. Some people have programming experience and they can breeze through this stuff, and I don't want to stand in their way. Other people have never programmed before and they would like a little bit more guidance to the prep work, and that's kind of what these sessions are for. So I'm going to go through the prep work, starting with, I'm going to focus mostly on the coding exercises because I think that's where the most value comes from. But what I'm not going to do is just stand here and read the textbook to you. I trust that you all know how to read. So there's a fair amount of content here. I'm hoping that you've at least taken a look at this before coming today. If you don't understand it, then that's okay. That's a good reason to be here, actually. But I do hope that you've at least taken a look at this, gone through it, and have some awareness of what we're going to be covering before showing up, because ultimately you are responsible for knowing this information, right? No amount of me standing up here talking changes that fact. So if you walk out of this room and you still don't feel like you know this material well enough, it's still your responsibility to go through this and make sure that you do know it. So come to office hours, come ask for help, whatever you need to do. Just make sure that you know this stuff. Okay? So if you are interested in submitting your assignments and things like that, that's what the TAs are for over in the Urbauer Computer Labs. I know that, so like next week, for example, assignment 1 is due during this time slot for you, right, by the end of class. You can also submit your homework assignments during office hours. In fact, I think that most people generally do submit their homework assignments during office hours. Class time is typically pretty low attendance in the computer labs, since so many people demo during office hours. And so if you want to come to these sessions in particular, I think that's one good way to think about it. Or you can also set up an appointment with me. I'd be happy to demo with you in my office whenever you'd like as well. There's a link for that on Canvas. All right, any questions about logistics and that stuff before I hop into coding and all that fun business? Yes? Demo, yeah, no, thanks for asking. So in order to get credit for work, you have to show that work to somebody, either a TA or an instructor. And so the way that works is you're going to go to office hours or class, the Urbauer Computer Labs, when the TAs are in there, and sign up on the list, and they'll call out your name when they get to you. And then at the bottom of every assignment, there is a rubric. So if you go to Canvas, I don't have Canvas up right now, but if you go to Canvas for assignment 0, there's a rubric at the bottom, and same thing for assignment 1, and that's the demo. The TAs literally pull up the rubric and walk you through from top to bottom and just check you off, and you shouldn't, if you get everything, you should know, honestly, before you even start the demo, how you're going to do, because the rubric's all there. I'm hoping that you'll have a good idea of how your code works before you start that process. Yeah. Thanks for asking. Any other questions? Yes. I'm still settling it, but it should be the Urbauer Computer Labs. I just don't know which one yet. But they don't start until next week, so I'll definitely know by then and post it on Canvas once I have it. It'll be in one of the computer labs, though. Sunday. Any other questions before I hop in? Yes? So that happens in real time. Like you sign up for a demo when you are ready for a TA to call your name and do the demo at that moment. So you will be physically in the Urbauer Computer Labs when you sign up for that. Yes. I know it's a little bit confusing. I know this is not the way that a typical class is run, but it does work, I promise you, and you will get used to it. It'll just take a couple weeks of getting into the rhythm, but you'll get there. Any other questions or concerns I can address before I hop into code for today? All right, fantastic. So let's start talking about programming. So I've already loaded up the exercises repository. I hope that you all have gotten this loaded up as well. We asked you to do that last week in class. Some of you maybe have already even started going through this and doing some of these exercises. If you open it up and you look, so they're labeled for Module 1, which is what we're doing today, right? We'll do 2 and 3 later on. And if you start opening these up, there's actually a lot, right? And it can be maybe a little bit intimidating to look at these and be like, wow, that's a lot. But I want to maybe try and help temper your expectations a little bit with the idea that we're getting started and we're taking baby steps, lots and lots of little tiny baby steps. So each one of these programs, each one of these exercises that we're asking you to do is actually a very, very, very small, very short exercise meant to, illustrate one pretty simple concept. As we go through, the concepts are going to get a bit more complex. Programs are going to get a bit more complex, a bit more complicated, a bit bigger, right? So right now, it looks like there's a lot of files, and there are. In the future, there will be fewer of them. They'll just be bigger and more complicated. That's kind of how things generally work. So don't get too scared off. You'll see that we'll go through these rather quickly. This is the first program that we asked you to run just to kind of check and make sure everything was working the other day, last week. This is what we would call a hello world example, or it's basically the simplest Java program that you could possibly conceive of, right? And you might be looking at this thinking, well, that doesn't look too simple to me. There's a lot of weird stuff going on there, and you're not wrong. And it might make you a little bit even more uncomfortable to know that I'm not even going to explain all of this stuff today. By the end of the semester, I would expect you to know what all of these words do. But I'm not going to explain what static is today, or what void is today, or even what public means today, right? That's not what's on our agenda. For right now, what I want you to know about these things, you can treat them as sort of magic words, necessary pieces that we need to get something up and running. Every Java program is in what's called a class. So you'll see this at the top. This is the name of the class, which happens to match the name of the file. That's not an accident. That is 100% intentional. It's expected to be that way. Capitalization and all. You probably already noticed that the computer is very picky about capitalization, right? Wants all the capitalization to look exact. So you'll see that at the top, and then this next part, public static void main. These are very, very important words in Java programs, but again, you can just sort of treat them as necessary magic words that we need to get things up and running. For a lot of people, myself included, these are some of the first words that you type as a programmer. This is the first line of Java that I remember typing back in my intro class 15-ish years ago. So we'll see these things show up in every program for now, but what I actually want you to focus on is the stuff that's in the middle here, right? So these are called curly braces, probably not a character that you've seen a whole lot of before coming to this class, but these things are called curly braces. There's 2 sets of them, and for now we're gonna leave this alone. We're going to leave the curly braces alone. We're just going to focus on what happens in between them. That's what we're going to focus on for now. And we'll tie all that other stuff in later. Okay? Before we start actually typing some code, though, let's take I just want to take a brief moment to reinforce this idea that we're really here to learn programming, not Java. I do understand that, yes, we are using Java. We're looking at Java. But Java is one language out of many languages that we could use to learn programming. Much like people have different languages, computers do as well. But I think it's important to understand that learning how computers think and act is much more important than learning Java. And to understand why, consider this. I could ask you to write down instructions on how to do something on a sheet of paper, for example. I could ask you to write down how to make a peanut butter and jelly sandwich, for example, right? And you could write down the instructions on how to do that, probably in English, I would guess, right? Some of you may know some other languages. Some of you might know French or Chinese or something like that. And you might be able to write how to make a peanut butter and jelly sandwich in that language, right? In a different language if you want to, right? But the actual act of making a peanut butter and jelly sandwich is the same, regardless of whether I tell you to do it in Chinese or English, right? And the same thing is true for computers. I can write a program in Java, I can write a program in Python, I can write a program in C or R or whatever languages you may have heard about or will hear about as you go through, right? But if I want to achieve a certain goal, the steps for getting to that goal are going to be the same. It's just how I have to say those steps that changes. That's the language. So while yes, you are learning Java, and you can walk out of here saying that you've learned some Java, that is a fair statement, that's a true statement. What I really hope that you learn is the programming. I really hope that you learn the underlying building blocks about how a computer thinks. And then in the future, if you have a programming project that needs to use a particular language, okay, go learn the language, do what you need to do to get the job done. It's really that critical thinking, the programming that matters here. So try and keep that in mind as we go through. There's more than just Java going on here. All right, let's take a look at another coding example. If I take a look at hello example 2, you'll see that there's more than one way to print information, right? So in that last example, we saw just one thing. I didn't even run it. I should have run it, although it's sort of not the most impressive program in the world. When I tell it to print something, print hi there, you can see that just displays the message down at the bottom of the screen. We call this the console, right? If I go back to this second example here, I can see there's now 2 different ways to print. If I run this program, you can kind of try and decipher what's going on. You'll see that, okay, it says hi there, and then somehow the exclamation point ended up on the next line. So if we try and figure out what's the difference between println and print, most people I think can see the ln and say, all right, something to do with the line, right? Something to do with lines. That's exactly right. I print out hi, and then I notice that the there ends up on the same line, right? And the exclamation point ends up on the next line, and that's a little hard to see, but there's no other lines after that, after the exclamation point. So when I say print line, it says print out this stuff and then move down to the next line once you're finished. That's how to interpret that command. Whereas if I just say print without the ln on the end, it just says print this stuff out and then wait. You don't move to the next line, just wait. I might want to print more stuff on the same line. This is actually, these 2 commands have been around, this idea has been around long before computers. This dates back to a very, very old yet extremely influential piece of technology called a typewriter. You get down to the end of the sheet, and what do you have to do? You have to go, right? That's println. That's a println that you just did. You just moved it all the way back to the left side of the paper so that you can start typing on the next row. That's println. Anytime that you're not doing that, you're just printing, right? So that's kind of how you can sort of rationalize. I don't know. Maybe that's too old of a reference. People don't use typewriters. Some people do, but anyway. Any questions? Any questions about that? And then the one thing that I really want you to get used to is actually typing these out. So this poem example is in the textbook. You'll notice that I'm focusing on these coding exercises. It says open hello example. I did that, right? Open poem example. It gives us the classic starter to the poem. I don't care what you make the poem say, but they want you to add a couple more lines to it. And even though you might be looking at this and saying, okay, I get it. I know how to print stuff out. I really really would encourage you to type this stuff out. because I'm asking you to type out things that are different from stuff that you've typed before, like papers and things like that, right? I'm asking you to use keys that you've probably not used a whole lot before, characters that you've probably not used a whole lot before, right? And while those might seem like small things, you're going to need to get used to that. You're going to need to force yourself to get used to where to find those things. Your hands are going to need to get used to what that feels like. So I think it's important, as trivial as it may seem, as easy and straightforward as some of these exercises may seem, very important for you to get that muscle memory started by typing out as much of this code as you can. Writing as much code as you possibly can is the best way to get better at it. So please, 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 please do this. What does it say? Java is cool. I don't know. And so is my cat. Debatable, I suppose. I think it's pretty cool. Yeah. So just getting used to how these things work. Getting used to, you probably saw me having it drilled into my brain for 15 years. I don't even think about that semicolon at the end anymore, right? It's just like, whew. For you, though, that's probably weird. You're probably hitting the period a bunch of times still, right? I remember doing that, hitting the period at the end of the lines instead of semicolons first. Those are the kinds of things that are just going to take a little bit of getting used to. Okay. So then, we're not just going to be printing out text all the time. We're going to be doing some number crunching in this class. So if we want to do some number crunching, you'll notice that that's all doable as well. So here you'll see some basic arithmetic operations, and if I run this, we can see that the computer happily will crunch those values for us and print out the result, right? Here I'm printing out the sum of all the numbers from 1 through 5. I think the exercise says, all right, edit this so now that it prints out all the values from 1 through 10, or the sum of all the values from 1 through 10. And so, you know, that's not terribly difficult, right? I can sit here and type out the additional values that I need to make that happen. Let's think about what I just did, though. What if I asked you to now print out the sum of all the values from 1 to 100? Then you're probably going to give me a look like, seriously? Really? Don't do that. Don't, at least not like this. Not like this. So, you know, that's maybe kind of a problem, maybe kind of a limitation. We'll introduce some more tools that'll help us with these kinds of problems starting next week, actually. But for now, might just file that one away in your brain for a little bit until we come back to it. The other thing that I want to point out is we have to be careful about how we print out our values. This might seem like a very similar program to the one that I just wrote. I just want to compute this very simple expression and print out the result. But when I run this program, you'll see that it says 570 times 23 equals 570 times 23. I mean, technically not wrong, just maybe not what I expected to see there. What happened? Why did I not see the actual... I wanted to see one number here, right? I wanted to see the results of the calculation. Why didn't I? What happened? Okay, you used a word that I've not used yet, which is fine. I'm glad that you know that. But can you be a little bit more specific? How do you know it's a string? There you go. There you go. The quotes. The quotes are the issue here. When I put something in quotes, I'm saying I want you to do it exactly like this. Exactly like what you see in the quotes. That's not what I wanted here, right? What I wanted here was for it to do some math and then print that out. So the quotes really aren't necessary. This is our first taste of why data types are really important. So the gentleman over here mentioned that I treated this as though it were a string. That is, in fact, what I would call any kind of text representation. Anything that I see inside of quotes, that's a string of characters. Whereas here, I wanted these to be treated as numbers. I wanted these to be treated as mathematical values, not text. So having the quotes there was treating these as the wrong data type, the incorrect data type for what I wanted. Okay. Let's see. So then, I know I'm not doing every single one of these exercises, but if I'm skipping a particular thing, though, please yell at me. I'm happy to look at anything that you all want. But for now, I'm going to jump ahead to take a look at some of the different kinds of syntax errors. So we actually already talked about those calculation examples. All right. I'm betting that you've already seen some syntax errors. In fact, I've already made some syntax errors. If I take the semicolon off the end, right? It's a classic example of a syntax error. Eclipse highlights it in red, underline, and says there's a problem here. And if I hover over the message, it even says syntax error. All right, syntax error. Insert semicolon to complete statement. So it's trying to help me out, right? Eclipse is trying to help me. Anytime there's an issue with semicolons, parentheses, brackets, things like that, quotes, those are going to be examples of syntax errors. English can have syntax errors too, right? You can forget the period at the end of a sentence or miss a comma or a quote, right? Those are also syntax errors in English. The difference is when you're talking to another person, or even if you're writing to another person, you make a syntax error, chances are they can probably still figure out what you're trying to say. Computers, however, so picky. So picky. They need everything exact. So one little thing out of place and nothing will run. That's what a syntax error is. Anytime you see that red underline, it's a semicolon, parenthesis, quotation mark. So parentheses, right? If I have an open parenthesis, it has to be matched with a closing one. They have to be matched. If I have lopsided parentheses, that's a syntax error. It'll say, I don't get it. Here, right? It's expecting a parenthesis here. And then maybe some of the worst kind of syntax errors that you'll see is typos. Just plain old forgot a letter, or added an extra letter, or just misspelled something, right? These are tricky. These are tricky because if you forget a semicolon, Eclipse can usually tell you, put the semicolon there, put the parenthesis here, right? Eclipse can sometimes help you fix those things directly. But if I look at this error message, it says this thing, you know, prit ln is undefined. Basically says, I don't know what this is. I don't know what you're talking about. I've never seen this before. And the reason is because there's a typo. You typoed it. So it doesn't know that. It doesn't know that there's supposed to be an N here, right? The computer can't figure that part out for you. But you're just going to have to be a little bit careful. Spelling is important, which kind of bums me out. I hated spelling a lot too, but computers care about it a lot. And so the next few examples that we see here, hopefully these should be fairly straightforward by now. I'm missing a quote here, right? Oops. It's missing the quote for that error. For error number 2, looks like I'm missing the parenthesis on the end of the line. And then finally for error number 3, this one's a double. We got the semicolon, but then up front here, here's an example of capitalization. This looks correct, but it really does want this to be capitalized. And if you ask me, you know, why, the best answer that I honestly can give you is because it said so. There are sort of rules and things that you'll get used to, but you know, a lot of these syntax kinds of errors are purely for the computer's purpose, get everything exactly where it needs to be. We bring these to your attention now because, believe it or not, as a programmer, I spend more of my time fixing mistakes than I do writing code, which genuinely surprises a lot of people, but it's true. And if you ever become a professional programmer, I think you should expect that to be true as well. can be sort of a rude awakening for some people. Yes, I do write new programs. Yes, I do write new code all the time. But every time somebody writes something new, they also make mistakes. It's called being a human being. It's called being a person. And so we actually spend a lot of our time fixing mistakes, finding mistakes, making sure our program actually does what it says it's going to do. Because there will always be mistakes. There will always be problems. There will always be things that need to be fixed. So figuring out how to find these errors and how to fix them is actually a very, very good skill to get used to as a programmer. And I would even go so far as to say that, I would push you to, let's say you find an error like one of these. I don't know what this means. Or it doesn't matter. Maybe you don't understand what happens. I took the quote off. All right. It says string literal is not properly closed by a double quote. Maybe you understand what that means. Maybe you look at that and you're like, huh? What are you trying to say to me right now, Eclipse? Right? If you don't understand what this error message is, there's absolutely no shame whatsoever in copying it, coming over to my good friend Google, and pasting that error message right in there. I do it all the time. All the time. Even I do not always immediately understand what the problem is when things go wrong. And I have to look stuff up too. And I've been doing this for years and years. No shame in doing that. In fact, the opposite. You should be proud if you recognize that you need to do that and are able to come up with a solution this way. That's programming. That's being a good programmer. Don't be afraid to go look for yourself. Take some initiative. Okay? All right. I think that's it for this first section. You'll notice that I did not do any of these, mixed up code examples or the multiple choice questions. I mean, if there are any of those that you would like for me to do during these review sessions, I'm more than happy to do so. In the future, I'm really hoping that these will be directed more by, your questions and things than by me standing up here talking. But yeah, please holler at me if there's anything in particular that you would like me to do. Otherwise, I'm going to move on to the next module, the next section, section 2. Okay. So up until now, we've been just having our program show us everything. Yes, we are doing more than one thing. So if I look at the computation, I can see, all right, there's 3 things happening. I start at the top, I do the first line, then the next, just like a book, right? Start at the top, work my way to the bottom. But I'm, computing something and printing it out right away. And then once that's done, this value is basically forgotten, right? The computer has no reason to keep any of these numbers around after that computation has been finished and displayed on the screen. But what if I actually need to keep it around? What if that's an important value that I need to remember for later? Maybe there's a lot of computations that I'm doing, right? And so I need that number more than once across many different areas. We can tell the computer to remember things using variables. So a variable is a way that we can assign a name to a value. That's essentially what it is. Much like you saw in your calculus class with those variables, it's the same general idea. The big difference between what you've seen in math class and what we're going to be doing in this class is that for us, our variables are always going to have a data type associated with them. So we need to pay attention to the data type that's associated with a particular variable. So today we're going to look at a few different data types. I've already shown you 3 out of these 4, actually, either in Studio or today in prep work. So we've seen ints, and doubles, which are both ways of representing numbers. Int being short for integers, so only whole numbers, both positive and negative. And then doubles is for decimal values with decimal places. The word double might be a little confusing. It stands for double precision, where precision means exactly what you think it means in the scientific context. So it really has to do with how precise these decimal values are. For our purposes, they're precise enough. And for most purposes, they're precise enough. And then strings, so text. This you can think of, it's called a string because it's a string of characters, string of letters, string of text. The other one that I haven't shown you yet is called a Boolean value. So it's not used for representing text. It's not used for representing numbers. Boolean values are a special data type that we use to there's only two values, either true or false. And to think about why these are so important to us, consider we're dealing with computers, and as many people I think are very aware of, computers use binary under the hood for everything, ones and zeros. So this Boolean data type is directly analogous to a binary, where a 1 is true and a 0 is false. That's where this idea for a Boolean value comes from this 1 and 0. The first three that you see listed here, ints, doubles, and Booleans, are what we call primitive types. And you'll notice that the text says that a string is called an object type. Other than the fact that you see that string is capitalized and these are not, that's very intentional, right? That is on purpose. I don't expect you to really know what the difference is between primitive and object types for now. You will later on in the semester. I would very much expect you to know what the difference is between those two. But for now, it's not really worth getting into too much. For now, I'm just interested in that you know that these are types. And so when I ask you to think about a value inside of your program, I really hope that you start associating types with those values. So for example, if I ask you to think about what data type you would use to represent the number of people in this room right now, there are a few different answers that I could possibly consider here, right? So of the 4 that I see up here, the only one that I think absolutely would not work is a Boolean value. There are true people in this room. What? That doesn't make sense, right? Not a good data type for that piece of information. String. So I mentioned that's used for text. I mean, I could store 0 as text, right? We actually saw that when I did the computation, right? The mistake with the quotes. So I can have numbers in strings, but you really have to think about what you're going to do with that information. If I want to perform some arithmetic, if I want to multiply, divide, add, subtract, strings, text, that's not, I don't multiply text. I don't divide text. So if my goal is to do math, then using string is probably not the good choice. There are times when numbers aren't intended for arithmetic though, right? Like a zip code. When's the last time you added a zip code? That's fine to use this string then. As for our example though, we're really down to ints and doubles, and I would even argue that one of these is more appropriate than the other. While you could certainly use either one to represent the number of people in this room, I would argue that there's never going to be 13.5 people in this room. At least I hope not. So I don't think double is the best choice for that reason, right? I think int is a good pick. That being said, there's some subjectivity to it. There's not necessarily going to be one right answer or one answer that is correct in all situations, right? You really have to take everything into context. Think about what you're ultimately trying to do. Okay? But yeah, this is a big part of our job as programmers, is thinking about how our data maps to these data types. The operations that are performed and how our program works depends a lot on these data types that we have chosen. And so once we've chosen that data type, we can create our variable. So there's actually 2 steps for creating a variable. We can break it down into the 2 different steps, or we can do it all in one go. So here I can see this is the first step, which is called a variable declaration. This is telling the computer that I'm making a variable called score, and it's going to have a type of int. It's going to be an integer value. What is the value of this? I don't know yet, right? As of this line, score does not have a value associated with it. I just know that it exists and that it is an integer. Okay, on this next line, this is a variable assignment. So this is, the way that we actually evaluate these is from right to left, typically. So take the value of 4 and store it in the variable called score. That's how I would interpret this statement. And so then when I print out the score variable on the next line, I would expect to see 4 there, right? So you can separate the declaration and the assignment. Those are two separate pieces. You can keep them separate as is done up here. It's actually, I would argue, more common to see it done like this, where I do the declaration and my initial assignment all in one line. Here I see, if I want to try to boil this down, I'm creating a new variable. What do I need to do? The first thing is I have to decide on the type. Here I've decided that I need a variable with type double. The next part is going to be the name. So it's up to me as the programmer to choose that name. I get to pick the name. Whoever wrote this program decided to call this variable price. But it's literally up to you. I really hope that you pick descriptive names that make it easy for me or even yourself to understand what your program is doing when you look at it. Because if you call everything Bob and George and whatever, it's going to be harder to understand what your program is doing, right? When you look at it. So please try to pick meaningful names. All right? And then once I've declared a variable, so I think this is another important piece. Once I've declared a variable, I do not have to declare it again. I can then assign that variable as many times as I want to after that. So down here, I'm declaring a Boolean variable. Remember, Booleans can only be true or false. So here I've decided to set it to be false. If I did it to do something else, 7, well, that doesn't work. That's syntax, right? Here. It says, cannot convert from int to Boolean. This is I'm saying this is a Boolean variable equal to 7. And it's saying, well, you can't do that, right? The only two acceptable values here are either true or false. So on this line, I'm declaring a Boolean variable. I've called it 1, and I've set that value equal to false. That value then gets printed out, and then on this line, right, this is just a variable assignment. Sometimes people will want to do something like this here, right? 1 is a Boolean variable. I'm going to tell you that it's a Boolean variable. This is redundant. You can see that the computer's not happy about this either. You don't have to do this. You don't have to do this. I already told you it was a Boolean variable. That's not going to change. It will always be a Boolean variable. So I don't have to keep telling you that. I only have to tell you the type of the variable the very first time when I declare it. After that, I can reassign the variable without having to say what type it is every single time. Does that make sense? I hope. Any questions? Any questions? Okay, cool. So let's talk about how the types can actually change. The types of our data can actually affect the operations that we're doing. If I look at something like this, I see quotes. That tells me text. That tells me string, right? Then I see, all right, score. I look at the data type here. That's an int. And then I see this in between, which I would assume is addition, arithmetic. Text plus 0, right? The plus 0. What? Huh? Text plus number. Well, okay, hold on a second. So this isn't arithmetic. This isn't addition. The fact that there's a string here, actually, the fact that one of these things is a string, changes this operation from addition to an operation that we call concatenation, which is a very complicated sounding word for just taking two things and sticking them together, making them into one. So I'm taking this text and I'm taking the value of this variable and I'm smashing them together to make one thing. What's the data type of the result going to be, do you think? I've got a string here, I've got an int here, I smash them together into one value, which is going to have a data type of, would it be an int? Hard to make sense of it if it would be an int, right? How would I represent this part as an integer? That's clearly text. Trying to represent that as an int doesn't make sense. But the other option that we have, string, well, can I take this numeric value and put it in a string? Yes, absolutely, that's okay. So the result of string concatenation is always going to be a string. Always, always, always. Always going to be a string. So anytime you see addition with strings, it's actually not addition, it's concatenation. String concatenation, it's tacking things on to the end of the string, right? The data type dictates the operation. That's just one reason why knowing your data types and choosing your data types is very important. Very important. Okay? And so the rest of the examples, I mean, was there a question? Sorry. And so you can see actually on all of these examples, you can see I start with an int, the next one does a double, the next one does a Boolean. It actually doesn't matter the type of the thing that's being concatenated on the end, right? If there is a string involved, it is going to be concatenation, and the result is going to be a string, regardless of what this other thing is that's being added onto it. And so using this technique, we can kind of stitch our things together. You'll see what the output, you can see what the output looks like here, right? Takes the values from the variables and just tacks them onto the ends of the strings. Are there any questions about that? Yes?
Are there other examples of computer learning how to transfer the
So we'll actually see some examples mixing data types a little bit later on. Yes, the answer is yes. I have some examples to show you. Yep. So here's another example where they want you to write some code. They want you to write a line of code that says, you know, your favorite color is, and then concatenate this onto the end. Again, you know, I hope this may seem very straightforward. If it does seem straightforward to you, great. I'm glad. That means you're getting it. It means these concepts are being absorbed. That's great. Regardless, I hope you take a moment to type it out. You know, get used to these ideas. Get your fingers used to it. So I typed out what I want the first part to say. I close my quotes. I'll put in the plus. That's going to be string concatenation. And then I'll put in the name of the variable that I wish to appear at the end. Notice it's not going to say your favorite color is color. It's just going to substitute in the value of the variable, which is red. Favorite color is red, or actually my favorite color is green. If I change the value of the variable and run the program again, you can see that it just takes whatever value is currently in that variable and substitutes that in. Right? That's the power of variables. Okay? Any questions about concatenation? We're going to do some more arithmetic next. More math next. Alrighty. Let's see. We did variable declaration. I think we did all this stuff, actually. Concatenation. Okay, naming. Yeah, let me just talk briefly about variable names. I've already, asked you to try and pick descriptive names when possible. If you pick longer names, so here you see an example of a variable name that's made up of multiple words. The convention is to capitalize the first letter of every word except for the very, very first one. This is what's called camel case. I say it's a convention because the computer's not going to enforce this. The computer's not going to make you do this. It's people that care about this. This makes things easier for us as humans to understand things. So you can call your variables whatever you want. Like seriously, the computer will not. Well, the computer will stop you if you get really weird. But within reason, you can call it whatever you want. But if I see your code in class with some strange variable names, I'm going to ask you to try and do something more like this. And especially if you ever go get paid, right, to be a programmer, they're definitely going to expect you to fall in line with the accepted standards. Yeah. Yes, there is. So in some cases, we actually will capitalize the first letter. In other cases, we don't capitalize the first letter. And whether or not that letter is capitalized actually has meaning to us as programmers. If it's lowercase like this, that means it's a variable name. If it's uppercase, it's the name of a class usually, like string with a capital S, which again is something I would expect to talk more about around module 7. So we're a little ways away from those still. But great question, thank you. All right, let's talk about some arithmetic, some math. I already went through variable assignment, but what I think is important is that I really want to reiterate that when you're evaluating variable assignment statements, it's important to look at the right-hand side first. Evaluate from right to left. Because where people will get tripped up early on is they'll look at a statement like this, right? If we were in math class right now, this statement would have a much different meaning than what it does currently, right? If I say x equals y in math class, you would look at that and you think, well, I mean, either they are or they aren't, right? Like, I don't know. Here, I'm saying take whatever value is in y and put it in x. And put it in x. So if I walk through this code step by step, x starts at 3, y starts at 2, and I'll print them out. And then I say, all right, take the value of y, which is 2, and put it in x. So they are now both 2. After that line of code is over, they are now both 2, right? This is changing the value of x. It is assigning the value of x. And then down here, I now assign the value of y back to 5. This does not affect the value of x in any way. So x, after this line, would remain 2. And only y would be changed, and you can actually run this program to see the values as they go through. X is 3 and 2, then they're both 2, and then finally x is 2 and y is 5. So all of the variables are independent of one another, but I can use variables to refer to other variables. I can assign based on variables the whole bit. And so when I look at something like whoops, that's not the right one that I wanted. Which one did I want? Let me go back to the book. Here we go. So when I look at something like this update score example, here is another example of a line that can kind of confuse people when they first get introduced to programming. Again, if I was in math class, a statement like this would look really weird. Score equals score plus 1. How could that ever be true? There is no value that score can be for which this statement could be true, right? But that's not what this is. This is variable assignment. Evaluate it from right to left. I know that the value of score starts at 0. So now this is 0 plus 1, which is 1, and then store that in score. So this is just adding 1 to the value. And then I add 1 again. So now it's 1 plus 1, which is 2. I'm incrementing. I'm incrementing this value of score. It's not uncommon to see a variable defined in terms of itself. That is not an unusual thing to see. Any questions? Any questions? Yes.
So, like a rule in computer science, I guess. I'm just wondering when you're saying, we're learning Java, kind of, but we're really learning.
So right now I'm introducing you some building blocks, some very simple building blocks, how to manipulate variables. And then next week especially, things are going to start moving a lot more. I mean, when I say moving, I mean that almost quite literally. With just variables, it almost feels like I just have blocks, and there's not a lot that I can do other than just show you that they are blocks, which is kind of what I'm doing right now.
Yeah, I guess I'm just wondering if this was like applied to different language.
Yes, 100%. Absolutely, yes. Incrementing a value by 1, it turns out, is something that we do all the time. Like, a lot. Like, I think nearly every single program. That's maybe a bit of an exaggeration. But yes, these kinds of operations absolutely are things that we do. Now, to kind of get back to your point, would adding 1 to a value look exactly the same way in Python? No. Parts of it might. It would look similar. The word int would not be there because Python doesn't use that word, right? It would look a little bit different in that way. But you would see a variable declaration that would look much like this, and you would see, seeing something like this, like a line of code like this, could very well work in many other languages besides Java. It's entirely possible. Yeah. The semicolon is the one part, believe it or not, that might cause problems. Because not all languages use semicolons at the end of a sentence. Sometimes they use other punctuation or they don't use any at all. So those are the kinds of things that when I say it's not so much about the language, right? Like who cares what the period at the end of a sentence is? You know that the sentence is over. You know that this program is incrementing. Those are the things that I really care about. Yeah. Cool. All right, and so then, great. I know I'm skipping some of the coding examples here. I mean, part of that is just for the purposes of time. But again, if I skipped anything that you absolutely want me to go back and do, please do not hesitate to yell at me to go back and do that. I did want to introduce some operators to maybe help ease some of that frustration that we've been seeing. So how do I check equality? If I really do want to know, are these two numbers the same thing or not, right? We can do that. So here's what that would look like. When I see two equal signs next to each other, now I'm talking equality. No longer am I discussing variable assignment. This is quite literally asking the question, or I guess the way I think about this is it's making a statement. I'm saying 2 equals 3. And then the computer is going to look at that statement, and either one of two things is going to come back out, right? In this case, 2 is not equal to 3. So if I say 2 equals 3, the computer says false. So what data type is that? Boolean, yeah. So if I make this is called a comparison. If I make a comparison like this, the result of that is going to be a Boolean, true or false. So this is the opposite. I'm saying 2 is not equal to 3. So that's what the exclamation point is doing for us there. This time I'll say true, right? That is correct, true. And so if you run these statements, you can see those Boolean values pop out. That's one of the big reasons why we introduced those Boolean values to you today, because they do appear as a result of those kinds of operations. There's another operation that I want to introduce to you as well. It's called the modulus operator. Some of you might have seen this before in some of your math classes. It has surprisingly, many uses. It's somewhat simple to understand. It has to do with division. Specifically, I want to get the remainder after division. So when I look at this first example, I would say 11 mod 10. That's how I would say that. If I'm trying to compute this, 10 goes into 11 one time, but I don't really care about that. The remainder is 1, and that is my answer. Right? So if this was, 12 mod 10, the answer would be 2. Still goes in one time, but now I have a remainder of 2, right? For this one, 3 mod 4, 3 modulo 4. 4 goes into 3, how many times? 0, but I don't actually care about that. I care about how much is left over. The remainder is 3. The remainder is 3. There's 3 left over. Anytime the number on the left is bigger than the number on the right, the answer is going to be the number on the left. 3 divided by 4. 4 goes into 3 0 times with a remainder of 3. Right? Why do we use this? Why am I spending all this time talking about this? The most classic example, the one that's easiest for people to see, why we use this is for determining whether a value is even or odd. So if I look at 8 mod 2, 2 goes into 8 4 times, I don't care. The remainder is 0, right? It goes in evenly. And because the remainder is 0, I know that 8 is even, right? For a value like 9 that is odd, I'm going to get a remainder of 1. So if I take a mod 2 and the remainder is 1, the answer is 1, I know that number is odd. If I do modulus 2 and the answer is 0, I know the answer is even. And those are actually the only 2 values that I can get. Right? The remainder is always going to be less than this. The remainder, because if it was bigger, that means I could do one more division, right? Take one more out. Hope that all makes sense. I know it's been a little while since we thought about division in this way, but this is an operation that you're going to see showing up in this class multiple times. Another time that we use it is with time, actually. If you're converting back and forth between 12-hour time and 24-hour time, a lot of times people will just use subtraction, but actually mathematically it's a modulus operation that you're performing, grabbing the remainder. So, 20 o'clock minus 12, remainder of 8 is 8 o'clock p.m., right? Modulus. Any questions about the modulo operator or how it works? Oh, yes. Okay. Yeah. I'm glad that you asked. Yeah. So, and the answer goes back to what we're talking about today. The question was 2 divided by 3. It says it's 0. That doesn't seem right. It should be 0.66666. But it goes back to the data types. So 2 is an int. 3 is an int. An int divided by an int is going to be an int, a whole number, right? 0.66666 is not an int. So somehow, the actual answer got turned into 0. Well, let's think about how that works. The computer is going to try to do this. It'll actually probably even determine, yeah, it's 0.66666, but then it's going to say, well, they want an integer. And I've got this thing that's not an integer. And the easiest way to go from 0.6 to an integer, or any value to an integer, is to just chop the decimal off. You might look at that 0.6 and say, well, I should round it up. We're not rounding, though. We're actually just chopping the decimal off. So it computes it as 0.6666, but then it says, well, no more decimal. What am I left with? Just the 0. Anytime I divide and the denominator is bigger than the numerator, if I'm using integers, right, the answer is going to be 0. How do I fix that? Anybody know? Yeah. If I change one of these into a double by adding a decimal, a double divided by an int or a double divided by a double is going to be a double, so it will keep the decimal information. Yes? No, it'll keep as many decimals as it can. So I would expect to say 0.6 repeating. Yeah. I mean, in math, we know this goes on forever, infinity. Obviously, I can't do that, so it just goes as long as it can and stops. There is a limit, and I'd be happy to talk to you about what the limit is. It's fascinating stuff, but well outside the bounds of this class. So come chat to me in office hours sometime if you want to know. Any other questions about this? Yes? Yeah. Yes. Yeah, and and so actually that's the way that you're describing is actually exactly, kind of the way that I would expect to use it. This simple example seems trivial, right? Like, I don't actually need to compute this. I could just do that in my head. But we're usually going to use variables. So, int value equals 3 or 5. And then what I'm really going to do is value mod 2, right? Where value could be something that somebody typed it on the keyboard. I don't even know what it is. We'll get to that actually in just a little bit. We're going to talk about that very soon. And I think that's, a good point to make generally, is that anywhere I see a number, I can also use a variable as long as it has the appropriate data type, right? Operations are really just taking place between two values of certain data types. That's how the computer sees it anyway. The data types really matter. Okay, so we did modulus, and then, what am I doing on time? Oh, okay. I've got about half an hour, it looks like. Perfect. Please. Fantastic question. So the question was, what's the value of using an integer over a double value, right? Because doubles can capture a lot more information. Why not just use them for everything? It's a question that, so I would never ask you this on an exam or anything like that in this class, but since you asked the question, I'll tell you that it has to do with how much space values take up. So to store those decimal values, it requires a lot more space on the computer than to store a whole number, right? Because I have to remember the decimal point and all the values that come after it. And if I'm using a double, even if the number that I'm storing in it is a 7, it still has to remember 7.000000000 and write all that down. So it's using that space, even though I could just use an integer, which takes up a lot less space, right? So it really comes down to that. Yeah. In terms of correctness, like whether a program works, in many situations, you can get by with either one. Yeah, absolutely. And in many situations, I'm genuinely not going to care. Oh, yeah. It's not so much of a difference to which I would expect someone to get upset about it, unless they're specifically telling you up front that they're worried about space considerations or something like that. Yeah, great question though. Okay, so everything that I've done so far has been directly through code, right? I've created the variables, I've printed them out, everything's happened up here in the code. But many of the programs that we write, that we use, have people interacting with them, right? So our programs are only useful because I or somebody else can come up and do something with them. And so I need to be able to have a way to interact with people. I need to have a way to ask people to give me some information, right? I don't want this program to work for just the numbers that I typed in here in the code. I want the program to work for the numbers that you've given me as well. And so, the way that we do that is by having a way of asking the user to type something in on the keyboard, for example, or click a button on the mouse. I'll show you how to use the mouse a little bit later on this semester. For today, we're going to start with the keyboard, though. And the way that we do that is by using something called a scanner. So anytime you see a scanner or need to use user input, right, you're going to see a line that looks something like this. And this is another one of those lines that for now I'm not going to spend a ton of time on, other than to tell you that it creates a scanner for you that you can use to get user input, right? Which is a very cool thing for us to be able to do. As the semester goes along, this line will make more and more sense. But you can expect that I will give you this code when you need it for now. Or if you do need it and it's not there, then by all means, you're welcome to come copy it and paste it wherever you decide that you do need it to make it work. Regardless, this creates a scanner for us, and it actually stores it in a variable called scan. And so then down here, this is where we actually ask the user to do something. I say, please enter your name. So I tell the user what it is that I expect them to do. And then I use the scanner, scan.nextLine. What this does is it waits for whoever's at the keyboard to type something in and hit the enter key. And as soon as that enter key is hit, whatever they typed in will be read in and stored in this variable as a string. As a string. I'm hoping that it's the person's name, right? So if I run this code, it says, please enter your name. All right, I will happily oblige. And then it grabs it, stores it in the variable, and then just spits it back out at me. It says, hi. Okay? But be aware that, you cannot predict what the person at the computer is going to do. Your program is going to charge ahead regardless of whether they give you the information that you're hoping for or not. So if I say, please enter your name, and I say, cheese, then it's going to try to do it, right? Like, it doesn't know. The computer doesn't care. So there's some responsibility on your users. In this particular case, this program isn't doing much, so it's like not that big of a deal to type in weird values. But you can imagine in other situations that can make a big difference. If I'm expecting a certain piece of information to come in and I get something different. I can also do other values besides just strings. In fact, the scanner is, when you use the scanner, you have to, again, have an idea of the data type that you're expecting to be read in. So I used the next line because I was expecting text. Name is text. It's a good fit for strings. But if I was expecting somebody to type in their age, for example, like in this exercise, just like before, I create the scanner, I put in a prompt. This time I'm asking, how old are you? And this time, instead of using next line, you can see that I'm using next int. I'm expecting them to type in their age as an integer. And so, as the user, it says, how old are you? And if I play along nicely, everything works great. Everybody's happy. But they can't force me, right? If I type in cheese again, well, now we've got a problem. Now we got a problem. I want to make it clear, though, whose problem is it really? Like, you as the programmer, you gave them a message. You said specific, you asked them a very direct question, right? And they read that and decided to type in something completely different, right? Ultimately, that's not your fault. However, we're human. Your users are human. I'm human. We're going to make mistakes, right? And I'm sure we've all used enough, typed enough of our credit card numbers and personal information into computers to know that I don't want the whole thing to crash just because I accidentally forgot a number or something, right? We want it to be a little bit more forgiving than that. We want it to be a little bit more flexible than that. So right now, this is sort of a disappointing outcome. I asked you to type in something, you gave me the wrong thing, and the whole thing just goes, that's not great. Unfortunately, not much we can do about it for now, but definitely keep that one in the back of your mind as well. I would like to be able to solve that problem, and we can, and we will in the future. Cool. Any questions about that before I move on to the next one? Yes?
If the person decides to spell out different words, is there a way to convert from spelled out number?
Absolutely, but you'd have to do it yourself, yeah. Or maybe somebody's already done it. It seems possible, seems likely. I think the easiest thing to do, though, would be if you're having those kinds of problems, right? You would just need to be more specific, right? Or something like that. In fact, when you're getting to stuff like this, what we're really talking about is a whole separate area within computer science called human-computer interaction, which is, How do people and computers, like if I sit down and try to use a program, can I understand it? There are companies spend tons of time and money on these kinds of questions, because the last thing that you want is to spend all this time and effort to make a program, ship it out the door, and then have people try to use it and say, I have no idea what's going on. What is this? I don't know. I don't know how to use this. It's worthless, right? So these kinds of questions are important ones, ones that are worth asking for sure. Any other questions before I move on to the next? We got, all right. We got about 18 or 19 minutes, it looks like, which is a good amount of time for what I want to do. I think I'm done with this section, as a matter of fact. I'm going to move on to compound operators. I mentioned earlier the idea that increment is so common. And in fact, it's so common that we actually have more than one way to do it. So here's an example of adding 1 to a variable, right? If x was 2, and then I run this line of code, it would then be 3. Turns out we do this so frequently that we've decided to incorporate some shortcuts. And so you can do something like this, which is equivalent to what's directly above it. It's going to add 1 to x. In fact, this is arguably even more flexible, because I can add whatever value I want directly to x this way by changing this 1 to be whatever number I want, right? So this is just a shortcut for this. If I want to do 7, I could say x equals x plus 7, or I could say x plus equals 7, and those would both get me to the same place, right? They're equivalent. And then finally, this last one down here at the bottom, now this one is specifically just for increment. That's just adding 1. So whenever you see plus plus, that's adding 1 to the variable. It's a very, very, very common thing that we do. In fact, starting next week, you're going to be writing this all the time, I promise you. It's going to happen a lot. Same thing for subtraction. So the same shortcuts exist for subtraction. Decrement, so subtracting 1 is also fairly common. So saying x minus minus, also a very common operation, common thing to know how to do. These shortcuts for multiplication, division, and modulo, you'll see that times equals, divide equals, those exist as well. I don't use these nearly as often as the other shortcuts that are on this page. This one, and the plus plus minus minus, the plus equals minus equals, I use those all the time, all the time. And some of that might just be personal preference, I know, but I very, very rarely use these. So I wouldn't be surprised if you don't see these show up very often, but you'll see these showing up a lot, starting soon, next week, even, if not sooner. So just be aware of those, and there's some examples of using them here. If you're interested, you can go through and verify that all of these come out the way that you would expect them to. Somebody earlier asked about converting from one type to another. So we saw this a little bit when we talked about concatenation. Concatenation is a pretty easy way to take just about anything and turn it into a string, right? Because that's what concatenation does, is it takes a value and it tacks it onto the end of a piece of text. But what if I want to convert from a double to an int, or an int to a double, right? I can do that. That's an operation that's called casting. So if I have a value that's in one type and I wish for it to be in a different data type, I can actually convert it. That's called a cast. And the way that looks is going to be something like this. Anytime that I see a data type inside of parentheses, so here I see the word double inside of parentheses, what that's telling us to do is look at the value that comes immediately afterward and convert it to this data type. So I look at the value that comes immediately after this and I see the 1. That's going to get converted into a double, so you can effectively think it as 1.0, right? And now I'll get 1.0 divided by 3, which is that's going to give me the 0.3333 that I would expect. If this double was not here, which in fact is what's up here on the first line, right? We get the example that I talked about earlier, where it's going to be 0. But then take a look at this example. This is a common mistake that I see people make. I'm trying to fix the integer division problem, but because this is wrapped in parentheses, order of operations still applies here. Order of operations still applies. So it's going to do this first. 1 divided by 3 as integers is 0. And then I'm going to convert that 0 to a double. Or like, oh, who cares? It's still 0. Doesn't actually help. Doesn't actually do anything. So be careful with your order of operations. It's another good reminder of that. PEMDAS, or please, dear Aunt Sal, however you remembered it, right? That's still in effect here. The computer is doing the same order of operations that you learned in algebra all those years ago. The big difference now is that we've got more operators. Casting is an operation that you probably didn't learn about in algebra. And the Boolean operations that I'm about to show you are also going to be included. So if I look at, not these ones, I'm sorry, I wanted to look at, here we go. So we already saw some examples of Boolean expressions with the equal to and the not equal to, when I see double equals or exclamation point equals. But we can also do comparisons, or I would call these things relational operators. And I'm certain that you've seen these before as well, right? This is saying less than, and this is saying greater than. But think about it in this context. Just like we saw with equal to and not equal to, I'm making a statement here. I'm making a statement, and that statement is either going to be a true statement or a false statement. So the output of a relational operation is going to be a Boolean value. So here I'm saying age is less than year. Or if you want to substitute the values in, right? 15 is less than 14. That is false. That's a false statement. Here I say 15 is greater than 14. That's true, right? That's true. And then these would be read as less than or equal to, and greater than or equal to. So up, if I don't include that equal to, if age and year are equal, that is false. That is false up here. But if I include the equal sign, then that would be true. So be careful about that. And then the last topic that I want to introduce you to before we wrap things up with the remaining time that we have is this idea that there's a lot of mathematical operations provided for us. So as engineers, as scientists, or whatever reason you're in here, I think, obviously computers are used to do a lot of number crunching, and we don't need to reinvent the wheel every single time, right? Computing square roots is the same for everybody. So instead of you having to figure out how to compute square roots all the time, Java just provides you a defined way to do it. And those things are going to be found in the math class. So if you want to know what's available to you through that math class, you can type math dot, pay attention to that capital M, that's important, it has to be capital. And then you can see I've got pi in there, that's good, but then I've got absolute value, I've got the trig functions are in here, I see cosine, arctan, arcsine, so there's trig stuff in here. I'm not going to go through all these, you kind of get the idea. There's logarithms, right? All kinds of math stuff that Java provides for you, square roots, things of that nature. The one that I want to pay attention to, though, and one that we're going to be using a fair amount in this class, we'll use square roots and things like that too, but one that I want to talk to you about right now is random number generation. So it turns out that generating random numbers is very useful for many different kinds of things. And so Java provides a way to generate random values called math.random. Here's what it looks like. So this is going to pick 2 random values. And the way that it works is every time I tell it to pick a random value, it's going to randomly generate a value between 0 and 1. But we have to be a little bit more specific. So 0 can be included, right? 0 is a possible random number that I could be given. 1 is not. So 1 is exclusive. 0.9999999 is the largest random number that I can expect to get back. Not 1. Up to, but not including 1. And so if you run this, we'll see some examples of what random numbers might look like. There we go. Got 2 different random numbers. If I run this again, I would expect to get 2 totally different random numbers, right? It's random. It's random. So we can see these random numbers getting generated. And you might be asking yourself, okay, that's cool, random numbers, but like, why 0 and 1? It's possible that I want to generate random numbers between a different range, right? And so, you know, that's fine. If I want to generate random numbers between a different range, we can do that. It just takes a little bit of arithmetic. So math.random is going to be values between 0 and 1. We want to get values between 0 and 5. A little bit of arithmetic here, I think, could take care of that, right? Work through the lowest end and the highest end of the range. If this gives me back 0, 0 times 5 is 0. If this gives me back 0.99999999999 repeating, almost 1, right? That times 5 is going to be almost 5. So this should give me random numbers between the value of 0 and 5, up to but not including 5, right? I'll never get 5 back out, but I might get 4.9999. And so just with a little bit of arithmetic, I've changed the range of random numbers that I'm getting back out. And you might ask yourself another question. All right, well, you know, 0 to 1, 0 to 5. What if they all start at 0? What if I want to shift? Well, more arithmetic will get the job done, right? If I add 10, the multiplication shifts it from 0 to 5, and then adding 10 shifts it to be from 10 to 15. I've now shifted the whole range up. You see the math there? So with any combination of multiplication and addition, I can shift the range, I can make it bigger, I can shift it in any direction that I want to, and generate any random values that I would like that way. Yes? Yeah, great question. So how would I get this to be an integer? Any ideas? Math.random's giving me clearly a decimal, right? A double. So not rounding, I would actually use so rounding does exist, right? Just because I haven't used rounding today doesn't mean that you can't do it. Rounding definitely does exist, but I've used casting, and I think casting actually works really well here. You just need to be a little bit careful about how you do it, right? Notice that I wrapped the entire expression around parentheses. Think about what would happen if I didn't do that. If I put this integer cast out, it's going to cast what comes immediately following it. So math.random is going to get cast to an integer. Math.random gives me a value between 0 and 1. If I cast that to an integer, I'm going to get 0 every time, right? Every single time. So be very, very careful. I don't want to make this into an integer, right? I want to do the whole thing and then convert it to an integer. So do all the arithmetic, and if you run this a few times, you'll see that, all right, I got 13. I would expect only values between 10 and 15, but never 15. I would not expect 15 to come out here because of the rules that I discussed. You can run this as many times as you want till you're convinced. I hope, though, that you at least take a few moments and work through some of this math, make it all logically fit inside of your head, because I promise you that you're going to see that show up again on a homework assignment in a week or two. Absolutely. Okay. That, I think, is a pretty good stopping point. Question?
Yeah, when you convert that number to an integer, what's happening? Is it rounding
Great question. Yeah. So I wouldn't describe it as rounding at all. When I have a double and I convert to an integer, it's going to do what's called, the technical term would be truncation. It's literally just chopping the decimal off. Doesn't matter what that decimal value is, it's just gone, right? I don't have to look at it and decide up or down. I just say gone. Yep. The effect of that is always rounding down. We would call that the floor. It's another technical word for it, truncation, or just, yeah, however you want to think about it. Whatever makes the most sense to you. Any other questions before I wrap this one up? Yes. Question, I'm sorry? Question 15. In quiz 1? No, because quiz 1's not due until next week, or actually it's not due for 2 weeks. So I want to give you an opportunity to do the studio and the homework assignment and then do the quiz, which is the expectation. Hopefully you'll have a better time understanding the quiz question after you've done the studio and the assignment. I'm not going to give away the quiz answers just yet. Ask me again in a couple weeks, though, if you're still having trouble, okay? Thanks, everybody. I'll see you next week, hopefully.